Hello everyone, we are now live. Today, we will be looking at an attempt to make Radiance cascades inside of geometry nodes. Now, this will not be accurate, this is just a very surface level attempt at it from the pictures I've seen and some YouTube videos I've seen online, but the basics are, what are Radiance cascades? It's a method to do 2D or I guess 3D global illumination, depending on your implementation. And it's very interesting. So in this attempt, this will be a little bit slow because geometry nodes is all on the CPU, while this is supposed to be on the GPU. So what this basically does is turn everything that I have rendering, everything can have either just lighting. Lighting from objects just works. That's not the best explanation, but in this case, it is what I found. Yeah, let's just go and showcase what it does rather than me trying to explain it very poorly. So here we have a couple of objects in the scene, just ones with different colors. In this case, I have a geometry node setup that just assigns a vertex color to all of these, so I can change the color from green to orange, yellow, whatever. So in here, I can change this, and we can see it changes there. It is lagging because right now I'm working at 512 pixels on the X and Y direction, so I will lower that to 256, just for simplicity's sake. But the general idea with Radiance Cascades is that the rays are shot off diagonally like this, but every iteration you go up, the rays get grouped together, but the angles get more refined. So spatially, it becomes more sparse, but radially, it gets increased by a bit more. I can showcase this by actually looking at what the ray casts are seeing. So we have the ray position and the ray direction. So in this case, we can see that the rays, there are 4 rays, and all distributed like this. But then when we go up one level, we can see that the rays get more spaced out, but their angle, the amount of rays being fired out, is becoming more. So we can showcase this in another way by seeing how the actual pixels are laid out. So at level 1, we can see that there are 4 pixels in this case. One of the pixels actually hits the monkey head right here, because even though they're all centered in the center of the pixel group, they're all angled different. So pixel 1 hits there. If we go up another level, we can see that there are more rays being fired out in different directions. So this one hits the monkey, this one hits another part, this one hits another part, but we're seeing some red because this angle goes off a bit more in that direction. And then the next level, we can see that the groups are getting bigger, but again, more refined. So we're getting more general shadows, and we keep going up and up and up and up and up until everything is grouped together. So that's kind of, this is what the raycasts are seeing. This is kind of like what you would see on a GPU. There are different implementations, but from what I've seen, this one is the easiest for me to implement. So after we do all the raycasts with all the groups, we then average them per cell ID, so that we then get a very nice and averaged result. There are a few caveats for things I have not implemented yet, the main one being bilateral filtering. So we can see everything here is very square, very voxelized. It's not supposed to be that way. It's supposed to be blurred per cell. So this cell would reference this one and then just blur in between those. So that is how it should function, but in this case, I don't really have the knowledge to implement that into GeoNodes correctly with this specific version, and I'll get into that a bit more later. But if you're wondering how I get the ray position and direction, well, we have to look inside this ray info node group. So here, this is basically the setup for grouping the pixels together for the Radiance Cascade. So this one, it's a little bit funky, but basically, we take these cells, we snap them together, and here we average them by a group. So when it's at its smallest, it'll group 4, and then, or 2 by 2, then 4 by 4, then 8 by 8, and so on. Here, let me go and showcase this with the levels again. So level 1, we can see that these are just grouping 2 pixels together. Then let's just show the new result and not keep the old one. And then as we go up a level, it's 8 by 8, 16 by 16, 32 by 32, 64 by 64, and we keep going up until we hit just the level. But once again, if we turn off the averaging, we can see the actual data. So there you can just see all of the pixels. Again, they're being grouped together, but the amount of diagonal rays goes up. Again, as we can see. Let me go and bump this up so that we can see it a bit better. So here are all the rays coming out from here. I feel like I'm doing this part wrong because it feels like there's too many rays in this case. I think this is the 64 by 64 version. So there will be a lot, but it feels like too many. But that does bring up something else. So here we can see, I believe this is 16 rays. So this is a 4x4 pixel grid, but 16 of those rays. Let's switch between the there and there. Both the same, different ways of visualizing the data, but the data is the same. In this version, there are several implementations that I've seen online. This one is using just a kind of pixel, like a subdivision level, almost, to put it in Blender terms, where the pixels, the grouping, doubles every single time, or so it goes 2x2 to 4x4 to 8x8 to 16x16, 32x32. But that causes it to go up by the square, and it doesn't just double. While the original implementation that I saw from a talk online, which I believe was linked in one of the Blender chats, I forget where, but it would double and not go up by the square. So this one is more expensive than it should be, I think, but I did see an implementation do this. So this is the simplest one, and I will go and show other ways that I've done this, because I think I have three so far. But yeah, there's the 4x4, that's the 16 by 16, 32 by 32, 64, 128, 256, and then, or no, this is 256, and then this is just 512, every single ray. So the amount of ray casts happening per level does not change. Every single time it's doing, or in this case, 256 by 256. So that's like, I forget how many pixels that actually is. But every single time it's doing the same amount of raycast, just their distribution and angles are grouped differently. I hope that's I hope that was understandable. At the very least, it looks pretty cool when you do this part. Let's see, that looks like what my GPU output looked like a few months ago. Yeah, like here we're just seeing the base data, or to a degree. Like this is just the pixels, what they output before they're all grouped together, and all the post filtering and such. But again, we can go and move around all the objects. We can see that the lighting seems to work out pretty well. Here, let me go and turn on the averaging again. I'm doing this on the face domain instead of the point, just because the distribution is a little bit easier to work with, and we can visualize everything easier because, well, if it's on the faces, it's just easier to deal with. So here we go, we can see that the lighting's over here. And again, this is I probably screwed up a significant portion of this setup. But it seems to be working to a degree, so I'm okay with it for now. But yeah, here we get the group, like where the rays are actually going to be fired out of. Here we get the ID, which is just, you know, we do a kind of CRT scan line, 1, 2, 3, 4, then you go up a level and it keeps going up and up and up. And then over here, inside of that group, this is where we get the angle that the ray gets fired in. So we get another local index where, in this case, let me go back to the just output. Here, it just goes like 1, 2, 3, 4, 5, 6, and it keeps going up. Every single one needs an index. And then according to that index, actually, wait, I can actually show the data. Let me go and just put this in here. Here, we'll just plug this into here, and I'll label it A. We'll go into the shader editor and just show A. There we go. So here we can see this is the index for the angle. So let's go back into the GeoNode editor. And then we go and do a couple things so that's kind of normalized. As we can see here, it goes from 1 to 0, and that contributes to the angle. I am using a vector rotate node because I am lazy. I am very, very lazy. But yeah, there's the actual index where it goes 0, 1, 2, 3, and it goes up in the scan line, and then we use that for a rotation value, which that rotation value, oh wait, that's, here, let's change that to vector so that we can actually see it. This is where the rays are, the direction that the rays are firing. We can see that they are going in the X direction, then they mix, then the Y, and then into the negative, which is represented in black. I forget what flag that is. That's funny. For the group ID, I think we, here, let me use a random value to show the group IDs for this. I'm very surprised I was able to do this, but it's very interesting. So here we can see a random value for every part of the pixel grouping. So here again at level 1, that's the lowest, it's 2 by 2 pixels, and then it keeps going up every single time, which is pretty cool. Is there anything else I need to really go over? I guess I could show the position snapping. Yeah, here's the position snapping. So here, we scale the position and then we floor it to make every single one centered at the center. Then I add 0.5 so that it is in the middle of the pixel grouping instead of at the floor. So this is basically a round. Then we do that. So now this is basically saying, hey, this pixel, its actual position is right in the middle here, here, there, and there, and there. And that's what's fed into the ray position. And then for the fraction, let's just go and move that and plug it into there. We can see that that's just a UV map for these cells. That cell UV then gets translated into a cell index, and then that index is used for the rotation. Which maybe I could have done that a little bit better. Maybe a set, well, I probably should have used a sine and cosine, but again, I am lazy. And I just want to get the base functionality going. But yeah, with that, it's surprisingly simple with just this implementation. Is it good? It's probably very broken. But it seems, at the very least, to work okay. And the only steps that I really need to do after this are, again, the bilateral filtering per level. But that would be very expensive at lower resolutions, because with the way Blender works, right now there are still tons of pixels in this area, so if I want to blur this one, that one, and that one on this level, here, let me go down a level, it would just be very expensive. So I do need to find a way to properly group the pixels together to make it as efficient as possible, which I will show in the other examples. But again, as we can see here, we can just move this around, and the lights in quotes, seem to work pretty well. Now let me lower the levels. It does seem that when the levels go too high, it freaks out a bit, just because, like, if there's a light in the center and there's only one cascade in that area, it freaks out. But I'm going to assume that's just because I don't have the bilateral filtering. Again, I can change the vertex color that is being referenced, and yeah, I should go over that part. So here we can see this is the quote-unquote rendering engine part of it. Again, very basic. We just take the objects in the scene, do a ray cast. We get the vertex color, which we assigned on all of those objects. We put in the ray position, ray direction, do all that. And if there's a hit, then okay, let me explain this a little bit better. So here we say, what's the hit distance, which this is way too big for that, and we set it to be a maximum so that it doesn't go into like infinity when it gets close to the surface. So this is the this is the light over distance. I did use a power just to make the fall off a little bit different. Now I don't think that's probably not correct. If it hits, then it works, but if it doesn't hit, that just doesn't get calculated. And then we multiply that by the color. So that's how we get the actual colored lights. All that cool stuff. That's that. And this could be done in 4.1. I initially implemented this into 4.1. But I also plan on... I have an experiment for today, because in theory, potentially, I can use the Ray Portal node to make this in cycles, which would make it a lot more efficient. But we'll have to wait and see how that implementation can go. Could this not be a shader? It should be. It should be, but I'm not sure. I wasn't sure if Blender had the capability of doing that with the pixel grouping, and the averaging. But with the ray portal node, I think I may be able to hack something together, and with transparency layers and all that good stuff. Any news on the 4H node? None. There's none. As far as I know, it is planned, but no active news as far as I know. So here's another variant of it, which, oof, it is so laggy. Is that because of OBS or just, this was another variant of it, which is more complicated, which is using basically, yeah, how do I showcase this well? Basically, instead of the, oh, yep, there we go. Just go and showcase the levels again. Yeah, there we go. So here we can see that these are represented as just points instead of a grid. And the grid scale goes down, but the points and all that go up. It's not, this was the first test of it, but it wasn't great. We can see the 4x4 pixels, but this does have the advantage that it goes up, it doubles the amount of rays, or doubles the amount of rays in the spatial area per step instead of putting it up by the power, which means that this gets exponentially cheaper over time. Or it gets twice as fast every single time in terms of ray cast count, I think. While the other one stayed exactly the same. This is what I saw the original implementation do by the creator. But I don't think I fully did it right. Now here, this is a bit of an approximation because I'm showcasing like the rays in the circle. They just fire from the center outwards, but this should be at 0, but that's a little harder to visualize. Let's see. My hopes are that it still appears one day. It is planned. It is a necessary part. The Blender devs have very big plans for geometry nodes. And they were somewhat, I saw recently a dev talk post about how to replace the old hair system. And for that, there's a lot that needs to be implemented in terms of like simulations and the UI and stuff like that. And I think a for each loop might be, or, oh no, that was the lists, not the for each loop, but maybe it can be used as well. But the for each loop, it is planned. It is very much planned. It's not canceled or anything like that, so it probably will arrive sometime in the future. So here we can see with this level, we can see, with the way I have it set up, that the levels are just visually represented in space, rather than it just adding to the previous attributes. In this case, we can see that there's similar things, so here we calculate the light, as before, on all those pixels. The source position is the same and all that good stuff. But here, the average, we take all those points that were there that are in that kind of circular array, as we can see here. And then we stack up all the values and then delete all the vertices except the first in the said group. So we only have one for all those. And then I instance a square on all those points so that we can see the averages, which leads to some cool artifacts, even if it's not quite, you know, it's not as good as the other one because it's significantly more hacky. But it is a way to visualize all this. So, and then this last one is more complicated because it needs 2 loops. I was testing if doing a repeat zone for the pixels or for the grid size would be more efficient than doing this stuff over and over again, but turns out it's basically the same. I think this one accurately has the doubling happening, but I would have to double check on that. Is this 256 or 5? Oh no, that one is 512. Okay. Wait, how's this? This one does not look like it's 512 by 512. Apparently it is. Maybe it's not being weighted properly when the new stuff gets yeah, doesn't look like it. So here we have the first level, then we go to second. Now it still doesn't look right. Looks like it's adding too much to all of it. But yeah. We can just see that more of the spaces get filled in, but yeah, it's way too bright. Which actually makes me wonder, why was the other one so... Oh, that was because Yeah, okay. So I need to... Yeah, that division is necessary. So I think... You know, that should work as intended. Let's just ignore that for a quick second. Yeah. Yeah, that is the setup. Let's see, anything else that's needed? I think that's all good. So I think I will pivot to Blender 4.3 because I want to try this with the Ray Portal node. Now you may be wondering, wait, why 4.3 instead of 4.2? Well, that's because I want to use the compositor with multiple passes because I may need to use AOVs in order to make it work. Potentially. But yeah, let's go and try that really quickly. So let's be right back and let's open this file in Blender 4.3. Don't save. I haven't updated 4.3 in the past little while, so maybe there's a few bugs and stuff like that. 4.3 is booting up. I really like the Be Right Back animation. I just made that on a whim, using geometry nodes for a significant portion of it, and it just worked out pretty well. Let's go and just find the file again, and go back to here. Alright. Toggle window full screen, there we go. All that is good. Okay. It's gonna take a while, because Eevee Next is a little bit slow in the boot up stage. But yeah, I was thinking how this will work. And I think AOVs will be the solution in this case. Because I just need to think a little bit about how this will work before I try implementing it. Because it would need a ton of transparency layers in order to correctly average everything. Which I am very worried about. Because the problem with this, the main issue with this setup is, in Cycles and Eevee, how do we accumulate all of these samples that we do? How do we take the cell average and stuff like that? That's the one thing where I think we'll be having quite a few issues with it. The hack would be to use transparency layers to get around that, because transparency, you know, you can stack up those and it's all good. But I want to see if it is, again, possible. So for here, yeah, and how would I do that? Because I already have the ray position and ray direction. We can just feed that in the ray portal node, and then that'll be good. That part is fine. I'm not worried about that. So let's go and do a little test with it. So we have all those all the layers right there. That part doesn't really matter. All we need visible is the actual surfaces. And the colors are the colors, so that should be good. Let's go into the shader editor, switch over to cycles. GPU compute, that's all good. And then use the ray portal node and feed the ray position. Now I'm using geometry nodes to just set up where the rays are. Potentially I could just have that work inside of the shader editor, but again, we're in the testing stage to see if it's even worthwhile. So here we can see that nothing's happening, which is not great. I was hoping that I would see a little bit more. Something, at the very least. So ray position, ray direction, and then... Dang it, nothing. Okay, what is going on? Maybe I need to make it so that the object is not visible to itself. So it can only be shown to the camera and nothing else. Really, nothing. Okay. Let me think about this really quickly. So we have... Oh, that's not showing up. Am I tripping a little bit? Shader editor. Radiance levels. Yeah, that one's radiance levels. So why is none of the data actually being visualized? Shader editor. Result. Yeah, that part's working, but not the ray direction. Ray direction is defaulting to 0. Or, ray position. Wait, let's absolute this just to make sure. AB. Huh. Did I spell it wrong in the GeoNodes part? Ray direction. And, oh, the position. Wait. The position is the face position, so we need to accommodate for that by just using the base vector. So here we just store this here, even though we're not using it in the actual, dang it, the actual input, I'm going to try it. So ray position. Again, I need to reiterate again and again, this is not going to be working well. I am not an expert in any way with any of this. So here, oh. Okay, the ray direction does not seem to be functioning correctly. But the other one, or no. That part is functioning, but we need more geometry to make that part function. Okay. So at least on a first test, we can see that the actual ray casting part is working. So that, there's a chance this might work. There is a chance. And if we look at the different, okay. Here we're just seeing one ray firing for each level, but that part is functioning. So if we then use a, oh, that's new. Huh, interesting. We need to feed that into the shader and the add shader. So that here, we can see that... Wait a minute, why is it still freaking out? Oh, wait, that's why. So we can see these parts are stacking. Now, they do seem to be noise dithering stacking, so that's not good. Here we can see that the raycasts are doing their job. But the good part about this is that we do not need to raycast on the geometry level, so that part should be, we just calculate the faces first for the ray directions and all that, and then that part works just fine. In theory, once again. So what I need to do is use a duplicate elements node, and then use that to offset the faces by a little bit, and then have that change the ray direction. So say on level 1, here we just have, you know, the rays doing that, but we need 4 duplicates of the plane so that we can get each direction and stack them up. Now, could I use noise dithering for this? Probably. That might actually be a really good idea. Would that work? If I just snap that. So here we are at level 1, but for the ray direction, I'll just use white noise. For ray position, no, we don't want that. This will be just the position for there, and then we feed into the direction. Okay, we can see that that is working. Oh wait, no, but that entirely defeats the purpose, doesn't it? Yeah, that entirely defeats the purpose, because the whole point of the Radiance Cascades is to not need noise dithering. But we're doing that. So, yeah. The whole point is to not use noise dithering, but this part, okay. So if we subtract and then multiply this here so that we only have that like that, and I guess we could do there because it already gets minused out. We can see that this is the lighting. So in one level we could do that, but it is, again, noise dithering when we don't want to do that. So if we set the noise threshold down, so yeah, the whole point is for this to be real time and not need noise dithering. But here, as we can see, with the lighting, it's just doing its job. So I guess in theory, we don't even need that either. So yeah, with the ray portal node, that's how, you know, you get shadows and all that. That makes it a lot, okay. So if you want to implement this in cycles and make it super efficient, because, well, I don't know. Yeah, it defeats the purpose using white noise in any of these steps, I think. But here you can see the kind of end result that is wanted. So yeah, if you're using cycles, it may be okay to do it this way. Yeah, I guess I could use this as a ground truth for testing the other parts. It's also interesting that the Ray Portal node is well, yeah, no, that makes sense. I wonder how else you could abuse this, because it feels like you can. So if we use a snap node, we will see... Yeah, there we go. There's one direction, and then the more we reduce it, we can see more and more of the samples, but it'll still be noisy because, again, noise dithering and all that good stuff. But since we're using the position, due to the way Cycles works, it's already stacking all of those levels. The thing is, I want it to be grouped so that I can do the Radiance Cascade stuff. Let's see. A repeat zone inside of a repeat zone. Yes, that is possible to do, and it's usually very expensive, but it does technically work. Oh, and we can play around with the Cascade part of it. I need to play around more with this. That looks very cool. Accidentally making spotlights. I have all this. Feels like the middle part here is a little bit iffy, but I'm not too sure about it. Here we can see the shadows. The shadows feel mostly okay. But yeah, the main thing about Radiance... So, someone just said I just entered. Can you explain what's happening? Here I am showcasing Radiance Cascades, which is a way of attempting to do global illumination, but without it being super heavy and inefficient, like without noise dithering and stuff like that. So here, this is happening on geometry node, so it is very, very slowly. But here, let's go and showcase this part. It starts off with a simple 4-directional ray cast, and then we keep going up with the angles more and more and more, and we group the pixels together as more of that happens. As we can see, the general global illumination is being stacked up. Now, I don't have bilateral filtering on this, so it isn't working all too well. And also, if we wanted to try this out with the noise dithering method, we can use well, this technically won't be correct, but as we can see here, since we are using noise dithering now, it'll basically do the same thing, but then you would need a lot of points to compensate for that. And also, this isn't accurate because it's, you know, the normalizing square random value isn't great. But here we don't even need to stack these things up. They just need to exist. And we actually don't need that part either. So this part is just the brute force method, where you just keep dithering and dithering and dithering. And also we need the levels to be plugged into there. Go, that's into the seed. And here we can see that the global illumination is happening, but we need so many iterations for a clean result. So that's the two methods. One gives very, you know, very accurate results, and as we can see, soft shadows, but the problem is that these shadows, the noise gets much worse the softer these shadows are. So the bigger this is, the worse it becomes. But with Radiance Cascades, at least when they're implemented properly, let's go and Control Z until we get it back. Even though the artifacts look so cool, like I'm going to be doing a couple of renders with that because they just look very, very interesting. Let's Control Z until we get that part back. As we can see here, we get a much cleaner result. Again, we're not doing the bilateral filtering, so it looks very voxel-like. But in just 5 steps here, 5 iterations, we get a very global illumination-ish looking result without all of the weirdness, without all of the noise. And it looks cool, so that's a plus. But again, with path tracers, they're all, well, not all, but they're mostly noise-based. Wait, where did... Hello? Oh, wait, I need to be in cycles for the Ray Portal version. Where are you? Oh, wait, and I need the parts actually visible for them to show up. But yeah, with this part, it's all using the GPU, which it is still fairly slow, which actually, wait a minute. Yeah, we don't need any of this anymore. We don't even need a high resolution plane, we just need a plane. So here, wait, why is that giving an error? Mesh has no, oh, that's why, okay. So here, this should be extremely fast, because we're not using geometry nodes, but it needs quite a few iterations to resolve in terms of noise. Which is rather, for 2 dimensions, you know, it doesn't take too long to settle. But if you want to do stuff that's a little more fancy, I think it may need some more. So yeah, it's an optimization issue. So again, right there, area lights and all that, and this could be any mesh. So ideally, you would have this, you would have the Radiance cascades on the GPU, and then it would be real time. One of my friends has done that in, not Blender, but in Godot, and it was very, very cool. The reason, if you're wondering, wait, why are you doing this now? It's because on one of the EV development chats, someone, I think 2 people, recommended Radiance Cascades for EV Next. Now, they were just suggestions, do not expect that in EV Next at any time. But I was like, I wonder if I can implement that in GeoNodes. Because I wanted to understand how Radiance Cascades actually worked, because all that has been... Stuff like this has been very difficult for me to grasp. Just because, like, I hear, oh, the ray directions and or the ray shoot out in these angles, and then they're grouped like this, but I didn't really understand how that translated into actual lighting. Where in this case, like, just with simple noise dithering, we can see, oh, yeah, the ray portal node does the ray cast, and these parts do the, you know, ray orientation. And it works. We could also go and set this to be a lot brighter. And oh yeah, that's looking so good. But yeah, here, let's set these back to 1 and then just use the vertex color once more. So here, that's being set in GeoNodes, which it's fast because, you know, it's not really being used for all too much. So there we can see, yeah, the actual illumination. Now, I did hear in the talk that this could be used for specular lighting, but I don't know how to implement that. Actually, oh, wait a second. It looks like this is being... Wait. Is this being... No, this is not being used for bounced lighting, because all the parts here are emissive. But if I were to use this here, in theory, this would... Oh, dang it. In theory, this could be used for indirect lighting. Like multiple passes. Which I think that might be happening. I am not sure. Let's hide a few of the parts here. So here, even the... Oh yeah, no, it is doing some bounced lighting there. So if we go to the light paths... there we go. And again, this is not using Radiance Cascades. In this case, it's just plain old noise dithering. But we can see that we are getting an artifact due to the white noise not working as it should. If we set the transmission to 0, velocity to 0, the diffuse to 1, or that transparency to 0. Okay. Total to 0, or actually no, let's set all these to 1. So if we have the transparency set to 0, we just get the first bounce, which the Radiance Cascade version is doing, and then here we get some indirect lighting. Now that I can't implement to the GeoNodes version because this is putting the light onto there, and then it's being fed back into the system in this case. But in the GeoNodes version, I can't put the color onto the geometry precisely. So that's why, again, it should be on the GPU, not the CPU. Actually, I'm going to use a rotate vector node, the axis, so that we can get a more accurate version. this needs to be a combined XYZ because we do not have a constant input in the shader editor. And then we need this to be multiplied by pi times 2. So this is so that we get a good angle for the ray direction instead of what was there previously. So before we can see that there was a little bit of a cross section here. Well, now that is not the case. So yeah, the Radiance Cascade is basically to do... It's a... I guess maybe you can call it a different kind of dithering, but I am not sure about that. But yeah. Basically, the simplest result is to just use noise dithering, but again, that is very expensive. But it is a lot simpler to do. So here we can see the rays, and they go around. I am surprised I don't need the... or no, for the Radiance Cascades, I thought I would need to use the AOV outputs, but that part's fine. How can I use the white noise to make a Radiance Cascade in order to... Like, instead of each part... Actually, no, this part's fine. Because the difficulty when translating this to the GPU and making it very efficient... Like, in Eevee, we can't do this, I don't think. That would have to be hard-coded in. How would I stack up the values if I had to by the group IDs and all that? I don't know. So for the time being, just having a noise dithering method in cycles would be the way to go if you wanted to do an example like this. But it is slow, very slow compared to the alternatives. I keep forgetting that these can be as small as I want because this is now using the actual pixel size rather than the other ones. We can see the lightings like that. And also, since this is using the GPU, the colors are not locked to the vertices. So I could just use a noise texture on all of these objects to affect the color. So if I do this, we should now see that that part is, yeah, there we go. The colors are doing their things. So yeah, there's that. I'm really just abusing the Ray Portal node for the Raycaster. Just using what Blender already has in there. But yeah, that is interesting. So again, this was just an experiment, but it is, it's pretty cool. So again, the ray info is the complicated part, and then the actual raycast, this would be like the this is the Ray Portal node equivalent. And then the iterations are just stepped instead of just dithered. That looks so cool. Look at that. Inside the original. Again, this is on geometry node, so it's using the GPU, not the CPU. I feel like some parts are still missing because this part should be filled in by now. But yeah, and let's also go and disable the cell averaging so that we can actually see all that great data. Because it looks so cool. Goes along, all that happens until we get a nice blob of pixels. Yeah, I think that one looks the coolest. Right, any last questions before I get, well, I finalize the stream? Oh, this is in cycles. No wonder it was feeling a little bit laggy. It will be laggy just because of how, Eevee works. Or just because of how Geonodes works. And I should also mention that this one is only doing one bounce. Well, no, I already said that. This is doing one global illumination step. It's not doing two. Because for two, you would need 2 steps to feed into each other, or multiple steps, depending on how many bounces you want. So this is just for the global illumination, but for the indirect lighting, you just need to run it again, but make this part affect the surfaces for the next round. I guess, yeah, how would that work? How would I make the surfaces function correctly? That's something that I do not fully understand. This looks cool. My question is that if we can do 2D fluid simulations using the ray nodes. In geometry nodes, yes. In the shader nodes, no, because you need previous frame data in order to make that work. And I don't think white noise would enable that. Like, I would recommend not doing that in Blender because Blender's just not made for that. Look, I really like the dithering look. That looks so cool. I think the bilateral filter would fix all of that because we can see that we are getting the soft shadows and stuff like that, and then when we group it together, yeah, it just needs to dither between the cells, or no, build a blend between the adjacent cells in order for it to properly function. That would eliminate all of the kind of voxely look, but maybe you want that. Maybe for whatever project you have, that's what you want. How would I do that using the ray portal node? I don't know. This kind of looks like Pixel PS2 graphics. I wonder if people knew about this in the PS2 era, if they could implement it. I do wonder how expensive it is compared to everything else, because it seems like it is rather efficient. Or at least screen space. Because in this case, well, this can be implemented into 3D for screen space global illumination, but for actual global illumination, it would still be expensive, but in the current version I have, since the spatial grouping gets halved every single time, or no, it doesn't, well, this one, every time you iterate, it's the same amount of rays every single time. While in one of the versions, the amount of rays would be halved, but the amount of space those rays would take up with their result in the grouping would double by the square of 2, I think. So one version gets cheaper the higher you go, like the more levels you go, and another one just stays the same level of complexity and slowness / fastness, I don't know, as it goes up. But yeah, just an experiment to see if my knowledge would allow for me to implement it, which it's not. Turns out it's not that complicated, which is making me think that I did it wrong. But again, the bilateral filter I just don't want to do right now, because with the current implementation, I don't think I can do that. Because for this, I would just need to... Actually, can I? I may be able to do it, but... No, that would still be expensive. I was thinking, oh, I can just select the first pixel in every single group, find the adjacent ones, and then blur them, and then apply that to there. But again, it would be too expensive to be practical because, again, it's on the CPU instead of the GPU. In this case, I hope the visualizer was cool. Here we can see that there's a little bit of... Yeah, that... Look at that. I need to use this to make some stuff, because even though it is, again, horrendously inefficient due to how I first implemented it, it's at the very least cool. So again, let's go and turn the transparency passes to 0 so that we can see what the cycle's ground truth looks like. So again, that's what that looks like. Shadows look like that. Then with the more bounces you do, more indirect lighting you get. Here, if we just have a little bit, we'll see some indirect lighting be bounced into there. And if we turn this up even more, we should see more. Again, this is using noise dithering, which is why it is inefficient. So how would I do that pixel grouping in the shader editor and then make it stack? Because I could just do multiple ray casts, like take multiple ray portal nodes and then combine them, but that feels rather archaic. Combine XYZ, so if, just to showcase a bit of this, if we do that, we get the ray direction from there, but I want that to be 1, 1, and choose a multiply node to reverse parts of this. So this will be -1. Then we'll add every single part together. So here, wait. Why is it not adding? Oh, because... Because it was... Oh, I put that into the position instead of direction. There we go. Okay. And then we set this to be... that, and then we can add more. So that... Dang it, dang it, dang it. There we go. So this would be like level 1 of the Cascade. Again, horrendously inefficient because I am being a doofus. But then we would need, again, more rays, because each one of these is representing 1 ray cast, and then we would need to do more for every single level. So, in theory, it is possible, and then I could do the group positioning to do a bit of that. So this is level 1, and we can do 3, 4, 5, 6, 7, 8, and 9, but you can imagine that would be very expensive with the amount of ray portals that we would need to repeat. So the question is, how do I make that better, but still combining the result? Oh, let me try to at least do a little bit of this. So I need the window coordinates, because again, we can just spatially do... Let me think about this real quick. So we have the spatial coordinates, and then I need to divide that by 2, or multiply it by 2, floor it, and then divide it by 2. So let's try this out. So multiply by 2, floor to snap it. Sorry if this is a little too mathy, but I am going to try this. So that, and then we divide by 2 in order to get the positional partitioning. This won't be oh wait, no, but that is in UV space, not global space. But can the window... No, I can just feed the position into here because it should be 1-to-1. So position, I just need to do an initial snap to how many... Yeah, what's the resolution? Sorry, I'm thinking quite a bit about some of these parts. So let me think about this. I just need to divide it afterwards in order to put it back into the global space and yada yada. Okay, let's have a value node, because I need to multiply it by however many pixels we have, which is 1024 by 1024. And then we floor that, and then at the end we divide it to put it back into global space so that it will read correctly for the ray position, in theory. So here we should see... we just connect that into the output there. No, it's not doing anything, which is not good. Okay, so position. Wait, why is that low? We have the geometry position, so that should be functioning. Oh, it's not connected to the output. That explains it. Why is it not working? Oh, you didn't connect it to the output. Something that happened yesterday as well. So if we set this to be 64, we should see 64, so that part is functioning. So just need to make this a little bit more elegant. So this decides our... Can this be used for grouping? That is the question. So we have a group of positions. I still need to make sure that the center is at 0.5. Transitioning this to the shader editor instead of the GeoNodes editor is a little bit funky, but I am trying to figure it out. So yeah, we have that. Okay, so that part's fine, and then as the spatial parts go up or down, we can make this part go up. And yeah, we can copy over some of the parts. Okay, no, this, I think this may be able to work. And this can still work in 4.2, I should mention. I was just being a little bit of a idiot with part of it. So in theory, I should be able to copy over a majority, pretty much all of this. And then that should work here. Let me just put reroutes here and here so that I can remember what parts are for there. Resolution goes there. And we will need to have node groups for the repeat zone instead of a repeat zone so that we can get the different levels. So I can implement the Radiance Cascade, but the grouping bilateral filter and all that is probably not entirely possible. So we have that, we don't need you anymore, but we have you. We can feed you into the local index right there, but we also need the other index, which we can... Okay, we have the floor, and then we... Wait, should that have been added? No, because that is the snap position. That's there, okay. So I kind of just recreated that part right there. So let's hide that part. We need the floor output to go... Okay, yeah, it's basically a recreation of that. So let me just go and copy you and have you be the snap position. For the local UV, see, that's scale, and then we put that into a fraction node, and then we should see... Wait, no, that's local UV here. Let me just copy that over. So here we should see, yep, that's a local UV if I ever saw one. So that part is functioning as intended. We'll put that right there. So we have that and that. So yeah, I have basically just recreated that first section, which is good, which means that I actually remembered how to do it. And then, yeah, okay. Group position, then we need the resolution into there, and then we'll need a repeat zone. Then that part should function as intended. Then the ray rotation, what goes into there? I'm assuming the local UV goes into there. And then that needs, oh, that needs to be a combined XYZ because we do not have a constant vector input over there. So we have all that, and I think I will just plug in some of the other parts. So this first value, we don't have an integer input. Regular old geonodes, that's for that. And then the exponent, what was that before? So the resolution goes into there and there. We need to make another group input for that. So for level 1, we should see that that part is... Okay, we have one part, which means that you are not functioning correctly. So let's look in the geonode editor to see what I was missing. Oh, that's the level counter. Okay. So right now, since that is probably reading as 0, it's not working as intended. Let's go over to here, the exponent that's reading as a 0, so we just need a value input. Value. Oh wait, no, we can't do that. We need to do this. There we go. So value of 1, we should see. There we go. Okay. So it is transferring. So we have that. We need to make this into a node group and then just repeat this a couple of times. The local index is for the grouping, but I'm not sure if we can do that. So let's go and... Let's see. Let me think about this really quickly. We have that, that, and that. So we can and should just be able to group all this, and it should be okay, and then we just add the different levels together. So node, make group, and then we have that and that. The first input right here is the level, and then this one is the resolution. Resolution. Sorry, I had to read that a couple times. So we do have an integer input to the shader editor now. When did that get included? Integer, but we don't have the inputs. Okay. So both of these can be... I think I heard that these were still floats under the hood, but I am not sure about that. So we have that. So we have level 1 is done. Let's just put default to 1 and default resolution to 1024 because that's what we can do right now. 1024, and that's doing, oh, okay. 1024. Okay, why are you not working? Oh, because the input was muted. There we go. Okay, so now we have that. And technically, because we're at level 1, well, actually no, we just keep upping the levels. And there, yeah, the Radiance Cascade is functioning. Just feel like something is a little bit off. Yeah, no, that's a Radiance Cascade. It seems like it. Again, not a professional at any of this, so I do not know for sure. We just do that, and then we put in as many as we want for all the levels that we want. So we'll set this to be level 4. Or wait, we skipped level 2, so that would be 2, 3, 4, and so on. So yeah, a fully GPU-based version of it. I guess I don't need the resolution input because that can just be the base. So yeah, there we go. And for indirect lighting, we just turn up the transparency passes, and then we get more of that happening. Is that still cascading? No, it seems like there's white noising. Like, it's trying to do it, but there's white noise in the mix of it. But yeah, okay. As we can see here, it is possible to make a Radiance Cascade in there, but we can't do the averaging. So how would we do the average? How would that work? Let's see, how would that work? Do I just put a ray portal filter over the top of it? No, that probably wouldn't work. It looks cool because it's dithering. And we do still have the group ID, so if I use, say, a white noise texture after this, let's set it to 1 dimension because it's for that. We should see the different levels of stuff. Like a different tint for every single level. Yeah, there we go. We need more levels for more stuff. Again, let's keep putting this here. We don't have a repeat zone, so this is what we have to do. And I'm putting the chain outside instead of inside because it looks a little simpler that way. Come on, buddy. Again, if we look at the output, we can see that the group ID is affecting the brightness of that part. Now, if I were to just have an emission, put this into the output, yeah, we can see the group ID doing its thing. So what happens if we were to look at the output there? Oh, that's cool. Go. And if anyone, again, if I am very, very wrong with all this, please let me know in the comments. Yeah. Let's see, very cool. I suspect that this shader method won't give any speed advantages due to each cascade still being evaluated per pixel sample. Probably in this situation, yes. No. In this situation, no. Because with Radiance Cascades, at least this implementation that's kind of pixel-based, the amount of rays being cast does not change every single iteration level. But it does feel more accurate because of the grouping. Again, level 1, it's just this. We can see that for every pixel in this 2x2 grid, one goes that direction, another goes that one, another one goes that way, and another one goes that way. But on the next level, these are groups of 4x4 pixels, as we can see here. So 1, 2, 3, 4, then 1, 2, 3, 4. So there are 16 rays in there, while there were 8 rays in the previous one. But they take up the same space in the world. Now, right now, yes, this is probably very inefficient because the amount of pixels that I'm rendering is, like, in here, there's probably, like, tons of pixels being rendered because it's taking up more space on the screen. But in the final render view, it is probably 1-to-1. And it is not because that was not actually being rendered. But why is there white noise still happening? I thought I limited all of the ray counts. Oh wait, that should be, no, yeah, that should be 0. So here we can see, the only adjustments that you kind of see is Cycle's doing like a first implementation of some stuff, which I forget what that is for. So, yes, it is more inefficient because We're basically making a render engine inside of a render engine. Or the resolution is not matching the current resolution. But if we use this, we should see that this stabilizes very quickly after that first initial pass. This right here is like 4 or 5 levels of the Cascade. But the things that we're missing in order to not, that is making it not actually work, is the grouping and the bilateral filter, which, as I showed with the geometry nodes version, groups together the pixel levels. So instead of us actually seeing the direct data, as in pixel 0, yes, no, no, yes, yes, no, 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 yes, no, no, and so on, it would just be an averaged value per grid cell. Unfortunately, I don't know how to do that. So I don't know how to do it without using like tons of ray portal nodes for it. Could I try using transparency layers and multiple pieces of geometry in order to make it work? Probably. Is that a good idea? Probably. Hey, wait. 1 second, everyone. I am cooking. Now that would just be just as inefficient as before. I was thinking... Here, let me think a little bit more about this. If I have another ray portal node where every single iteration I have would look at this pixel, this pixel, this pixel, this pixel, this pixel, and then so on, I could potentially average them up. And no, but that would just be super inefficient anyway. I don't think, yeah, no, I don't think we can do this at all in cycles. Without hacking it to hell and back. This is more of just a visualization of how it can be done, I guess. But there's still a lot that would need to be done. So we're 6 levels in here, as we can see at the different levels. And there's one. And once again, this one is not as efficient as it could be. Because instead of it going from 4 rays to 16 rays here, it should be 4, 8, 16, 32, 64. So this one goes 4, 16, 64, what's 64 times, 60, sorry, my brain just completely, crapped out for a second there. Too much math. But we're seeing that stuff is happening. Kinda how I've seen it in visualizations. Because my brain's just like, hey, let's try to recreate the pictures instead of, oh, let's try to do it accurately. On the plus side, this will work with, like, if the object's reflective, in theory, maybe that could work. So if I go into the shader edit, oh, double clicking for some reason. Okay, let's take a look at this. So what if this was just... I don't know how that would work. Oh my gosh. Oh, and something is tinting the output. I wonder what. Let's put a light into the scene so that we can just see this part, and we can put it there. So here the monkey is obviously going to be showing up on the light because of the, you know, just other render engine stuff. I was wondering if we would see that in the Cascade at all. It doesn't appear to be that way. I was hoping maybe a little bit, but I'm not really seeing it. That's not really showing up. Okay, so it should be like the... Actually, wait. Why is it not? Because the ray portal should be seeing that, just the end result there. Is it because there's not enough transparency passes? Yes, yes it is. So here we can see that the light is doing its job. But there's some weird stuff happening because, like, we're doing 2 render engines at the same time. Fuse. We want all these... I forget if 0 is infinity. We do that, and then we just put that up and up and up. Do we see bounced lighting? We change that to be 0. What happens then? I am seeing a little bit of a different... Come on, buddy. Alec. Feels like something's happening. But again, I have not nearly put in enough effort into trying to understand how it works, combining cycles with Radiance cascades, because that's probably a nightmare scenario. We can see in here, when the light is in there, you know, we get to see the data. But I'm assuming with, again, averaging bilateral filter, we would not see too much light leaking in that scenario. Like, look at that. So we are seeing bounce lighting here. So again, I was worried that with point lights, since they're, you know, this has this radius of 0, we wouldn't really see it all too much. But it turns out that it is working. It's just that the monkey here is not really working all too well because it is a 3D object, and then it's kind of interfacing with all that. I used the denoiser. I mean, yeah, it looks like it's working. And I'm not seeing any dither. Like, wow, look at that. Look at that dither pattern. I think I may be the first person to try this in cycles, which, again, I wouldn't recommend. I'm actually surprised that it worked. You know, it's not working well, because I can't fully implement it, but it is working. So here is just regular noise dithering. Oh, and by the way, something is really tinting the result, and oh, no, that's why. Because, wait, when did I do that? Okay, so here we have that, or that. This result is brighter, I think, because we're stacking up all the levels without, you know, actually averaging all of them. So in this case, I would just need to divide this by, how many layers do we have? Like 7? We have, oh, yeah, I forgot to turn that one up. Okay, so we have 7 layers. So for that, we need 1 divided by 7. So that should match with the regular white noise version. Looks like the values are matching. So yay, now I can test the ground truth with the Cascade. Let's turn off the denoiser in this case. So again, white noise. It resolves rather quickly in this scenario. But that looks cool. So the question is, do I stay with the GeoNodes version or use the Cycles version? Now, could this be implemented in Eevee? Maybe. Or no, we don't. Is there an approximation to the Ray Portal node in Eevee? I don't think so. Isn't this what started Half-Life? I think so, if I remember correctly. Okay, let's go and have the vertex color affect the diffuse color for this, and now we can see that that part is working pretty well. Let me only show the bounce lighting. We don't need any of those, so that'll speed things up. Indirect lighting is being clamped. But then here we only have 1 pass, so no indirect, or 1 pass. Actually, wait a second. So we have diffuse right here. Yeah, no, we don't want that. The only thing that we want is this part happening. But we need diffuse passes so that we can get indirect lighting, which will feed right back into the Ray Portal. So if we have 1 pass, set this to be 1, or 0, come on. A little bit of lag, which is causing a world of hurt. Is that what will cause indirect light? Why am I not scrolling? If we do that, we see indirect lighting, but that's just the regular thing doing its job. Here, if we do that, do we see bounced lighting at all? Would be very subtle. So I think I need to, yeah, let's go into the vertex color, the one that I made, do that, and then we can see, oh, is there any bounce lighting occurring? Here, anything happening? We should see some light over here, but no, I'm not seeing any. Glossy? Oh, Glossy's doing stuff. Why is Glossy doing stuff? So 0, and then there's 1. So that one is causing some indirect lighting to happen. Need to... Wait, why... Huh. So it is affecting it, but it's acting all weird. Yeah, I can't say I fully understand that. But yeah, if nothing else, this is a very cool test. We can have regular lights. Like, look at that. Wow. I need to sneeze 1 second. Phew. Sneeze has occurred. Okay, I think that's everything for today. Again, a fun... Oh, wait, that looked really cool. A fun little test, which can lead to some pretty cool renders. I wonder how bad this is for compression. Like, this is probably atrocious. But there's still noise dithering when there should not be. Yeah, I'm just going to assume that that's some weirdness. If we zoom out far enough, like, that looks like it, I'm scared to say, but it feels like it's somewhat accurate. To, again, with the limited amount of resources that we have. And roughness... Well, there's not really any diffuse lighting doing anything here. Oh no, there is just a tad. But yeah, the ray portal node doing its job. And I was like, oh, if we hide this, then we can see what's in there. But no, I would need to use a light path node with a mixed shader node in order to make it so that the actual objects do not show up in the camera. So is camera, or no, would that work? Camera, no, light path. Camera ray. No, dang it. Shoot. Transparent. Yeah, it has to be visible in the camera for it to go into the cascade and function properly. That's a shame. I thought that would work a bit better. Also, yeah, something funky is still happening with it. But we are seeing some stuff happen. Maybe I could use the transparency depth to say if it is over a certain amount, then don't show it. Okay, now that's only... Ooh, but that looks cool, though, because we can see the interior there. The only downside is that the parts that are underneath part there are still having a not-so-fun time. But I could just make it so that the objects are, like, over here, because I can move the ray portal's, like, virtual looking position. That would work. That would work. And we can scale this up without worrying about resolutions, because since we don't need an index, we can just scale this to basically infinity and call it a day. But that bounce lighting is still causing an issue, and my computer, I can actually hear the fan, which is a little bit odd. Set all these to 0. Yeah, that's looking pretty cool. Here, let's just go and... With that part, all the rays that are inside are reading as 0. I could just do... Yeah, let's just go and show the originals. Keep it as simple as humanly possible. We do that, it's just like, oh, so much light. Okay, let's delete... Oh, no. What I meant. Let's delete you. Sorry, I need to sneeze once again. Nope, sneeze did not happen. Okay. So, and also, since this can't be any object, I'm just showcasing it with just general, like, oh, here's a square and all that, but we can draw curves. So let's draw a Bezier curve and give the geometry a bit of thickness. Where are you? Wait, to depth. Yes, there we go, okay. Here we go, it now has some depth, which means that, over there, it is now blocking the light, so I can, wait. I did not mean to do that. In edit mode, we can now draw curves, just like in all of the demos. Yeah, draw, and let's also have an emission right here. Okay, that's a bit too bright. Let's go and turn the tube radius down by a bit. We can also have, we could have noise be the color. Oh yeah, color. That, let's not normalize it. So now we can go and draw curves, and then the cascades will be radiancing. And let's set it to 0 so that we can see the parts. So here we can do that just to cut off certain parts. Oh, and now the draw tool actually shows the vertices. Okay, let's turn on the molecule of bounced lighting, because we want diffuse one, transparent one. Yeah, there we go. So now that part's doing that. Why does this feel inaccurate? Like it's not drawing where I actually am drawing? Okay. So yeah, just like all the demos of Radiance Cascades that you see, this part does seem to be functioning. Just, I'll call it stylized because again, we're missing some vital components. Then we can plug this in once again, set it to like 3 to get some very nice multicolored lights. And again, we can test this with the ground truth, which is just, you know, dithering. So uncivilized. But yeah. Okay, I think that's everything for today. I don't see where I can take this further. I don't think we can do, again, the grouping and the blurring. So I think this is the best that we can get, just actually seeing the data. As we can see here, the more we zoom in, the more we see the data, and it looks amazing. Another funny thing, if we do not group the position properly, and then just, or actually no, that's incorrect. If we just have the position, and then group the rotation, get something that actually looks a little bit better, but it's, again, inaccurate. Local index we don't need because it's technically incorrect. The resolution. Resolution goes into there and there, but we don't need that part in there. So that part we can just up a bit, put a little reroute. So the resolution, I'll just have a value internally so that we can edit this when we want, and it will affect all the groups. The only thing we need to change is the level. So here it's 1024, so we can set this to be 4. So here we can see the cascades for that part, and then we can just keep turning up the resolution. Over time, you'll still have 7 passes, and then you just need to have more passes for the indirect lighting. So yeah, that is that. And we don't need that, we need glossy, I think, if I remember correctly. Okay, let me delete the curve because that is getting way too just visually noisy. And then we can just go and scale this to 0. I can go and just turn off the, Wait, why is that not showing anything anymore? Got rid of the geonodes, but that should be okay since we already have the part. Let's take a look here. Yeah, no, we don't need geometry nodes, but why is it not... geonodes. Yeah, that's Radiance levels. We're just plugging that into there. Actually, I will go and apply that so that has no excuse. There we go. Now we can just go and scale this plane, and then it does that. Again, this will work in 4.2 with the Ray Portal node. It does not need to be in 4.3. I was thinking that I would need to, Oh, wait a minute. Maybe that is the issue. I was thinking that I would need to get the ray distance and stuff like that, which I would need AOV outputs to output the hit position and then calculate some stuff, but I think... Actually, wait a minute. Yeah, that is actually something that I may still need to do. Because with this, the lights never fade. Like here... Wait, actually, will they ever fade? They won't. Okay. So maybe I still here. Okay. One last tangent before we get moving. I'll need to save the variant. We don't need those two. We just need those and that. Okay. So here for an AOV output, I just need to think really quickly. So shader editor. Sorry, I'm thinking really quickly. That's the vertex color. We don't need to worry about that anymore. What I do need to do is have an AOV output, which will output the position. And then we can compare the position to the ray portal position. No, would that even work? Well, let's try it and then see if it can function. So, is there a pass for a position? Okay, nope, this may actually work. Shader AOV, this will be position, or I guess hit position. Because that part will feed into there, and that's a color. Can I change that to be, well, yeah, no, that'll probably be fine either way. So, geometry position, no, well, let's make it the actual position, geometry position, there we go. Let's do a render, and then let's take a look at the compositor. Again, with noise dithering, we shouldn't have to deal with that, but... Actually, I need to check. I think I may just be on a useless tangent. So that's the AOV, which looks like that part is functioning correctly. Or no, that's not the snapped position. So no, that part won't be good. The hit position is working. So we can potentially do stuff with that. That part can potentially work. Set that to be 0 and... So if we can get the cell position versus that position, we can get the distance, and then we can multiply the color by that in order to make it work, I think. Because we can't get the distance from inside the portal, so we're doing it in post. I need to think about this real quick. Can I have an AOV output of the cell position? But no, that won't even work because we need multiple levels of the cascades. So no, this is useless. It won't work. A lot of this stuff, you know, cycles would have to be, I would need to have much more low-level control in order to actually do this. So let's just ignore that little tangent. That is unnecessary. So, yeah. Let's look. So, the fall off, I'm still just mildly worried about. Let's go and do that. Let's take a look at the Radiance Cascade. And just do that. Okay. So it is fading, but not as much as I would like. Maybe that's just the power of the lights, potentially. Nothing obscuring it so that it will just keep going in for eternity. So yeah, it is matching the ground truth as much as it can. Alright, so yeah, that is the attempted Radiance Cascades. Doing it in geonodes because we have more functionality in there, and then try and get in cycles with the Ray Portal node. Can't do it in Eevee because we don't have a Ray Portal node in Eevee. Maybe I could try to use Refraction in order to do that, but I highly doubt that is possible. Because I would probably need... Actually, is that even... I'll try that off stream. I won't try this now. We're already going for an hour and 30 minutes. Alright, let me read the chat before going away. Let's just do another quick check with everything in here. Yep, all that seems to be good. Again, the index is not needed in this scenario. It is funny that this is the most efficient, or the smallest node group to try to make the cascade. It's not the most efficient, there are more efficient versions, which is probably contributing to some of the errors. But yeah. Okay, let's read the chat. Let's see. What are we making? Playing around with trying to make Radiance cascades. Like, I went into this, like, this is not practical. Let me just say that. The Geonodes version is not practical whatsoever. The Cycles version is cool for stylization, but nothing else. Because Cycles is made for doing noise dithering, and there's a denoiser and all of that. But it's a cool experiment, which is the main thing. Let's see. Try to experiment more and come up with something cool and post a tutorial. I don't think this is tutorial worthy. Like, there's a live stream about it. I think that's good enough. Because it's not real Radiance cascades. Like, for that, I would actually need to implement it using, well, I would have to edit Blender's code, and I do not have the experience for that, so I'm doing it in the only way I know how. Let's see. Please post a step-by-step tutorial for dumb people like me. In this case, I don't think that would be beneficial because it is not a finalized effect. Very cool. I suspect the shader method won't give... Oh, wait, I already read that. Isn't that... Yep, I already read that as well. I just got here. No, yeah, the stream will be ending. Let's see. I just clicked on the stream, and that glitch effect popped up. For a second, I thought I lost my monitor. Yeah, it's, I guess because it is I'm trying to replicate GPU effects, it looks like GPU errors. Which, oh no, tons of sad faces here. Yeah, tons of sad faces. That's funny. How did I see that? Okay, but yeah, that is an attempt of making Radiance cascades. It ultimately was unsuccessful. It was semi-successful. It kind of looks like it, but it's not practical, so I'll call it unsuccessful, but interesting. Very interesting. Okay, thank you all for watching, and I will see you next time. Have a good one.